All right, this section of Chapter 2 deals with properties from algebra. Very, very important because this is the base for proofs. Next section, we're going to deal with geometric proofs. The way we ease into that is by learning about algebraic proofs. When you use algebra to solve geometry problems, one step after being able to solve them is explaining why you solve them or how you solve them. We use algebraic concepts in order to do that. Maybe you use the addition property where you just added two things together. Maybe you use the subtraction property. Maybe you use the multiplication property, the division property, the substitution property where you substituted a value in for something else. You use these different properties when you solve an algebraic problem. And you just know how to do it. You learned in algebra how to undo an equation or undo a problem using these different steps. Okay? You learned that subtraction undid an addition problem. Multiplication undid a division problem. You learned that if you have a formula and you're given some values, you can use the substitution property to substitute those values in. Well, now, when you solve a problem, especially today, when you solve a problem, you're going to explain to me, oh, I used the addition or I used addition. And that's going to help because the way that we go about solving these problems today and the way you justify your answers or justify your steps are going to help you in the next section when we deal with geometry proofs. So here we're learning how to prove stuff using algebra, something that we're all familiar with or that we all should be familiar with. And where we're going with this is that once you learn how to prove something, then we can use it and apply it in geometry, where we have geometry proofs. Let's look at example 1. Solve the following problem explaining how and why you performed each step. The first thing we're going to do in our problem, or in our box, under the equation part, we're going to write our equation. 2x plus 5 equals 20 minus 3x. Now the explanation for that is there is none. I mean, that's the problem that we started with. The reason that we wrote it there was because that's what's given to us. We're given the equation. But now let's look at it. The first thing that we're going to want to do to solve this is do what? Hopefully you remember that we want to move all our variables on the other side. If we move all our variables to one side, I'm going to want to move them all to the left. So I'm going to add 3x to both sides. The explanation for that is add 3x to both sides. And the reason that I can do that is the addition property. Now what I'll get out of that is 5x plus 5 equals 20. And I can see that my 3x's cancel out. And now what's the next step going to be? Well, it's going to be to move this positive 5 to the left, or to the other side. So the way I move this positive 5 is by subtraction. And so I'm going to subtract 5 from both sides. And what allows me to do that is the subtraction property. When I do that, the 5's cancel out. I'm left with 5x equals 20 minus 15, which is just 15. And now how would I solve this? Well, I would divide both sides by 5. And again, the explanation for that is divide both sides by 5 using the division property. Well, when I do that, the 5's cancel out and I get x equals 15 divided by 5 is 3. I don't need to do anything else. I am done. Finito. We solved a problem, or we solved an equation in algebra. We used algebraic concepts to justify ourselves, or we learned how to prove solving a problem using algebra. Eventually, you're going to get to where all these different things are geometry. You're going to learn to do a geometric proof. Let's go to the next page. There are other properties we use in geometry too. We use the addition property, the subtraction, multiplication, division, substitution. We also use the distributive property. And if you don't remember the distributive property, take a look. We have something times a quantity. The quantity is b plus c. What we do is we distribute using multiplication. Instead of saying a times b plus c, we say a times b plus a times c. We also have different properties of equality. We have the reflexive property, where a equals a, or the same thing equals itself on both sides. It's reflexive. It's like a mirror. It reflects. A equals A. AB equals AB. Angle A equals angle A. We have the symmetric property, where we're told that if A equals B, then we could also flip that around and say, then B equals A. We can make a symmetric statement. We also have the transitive property. The transitive property allows me to say that if A equals B and B equals C, then A equals C. Now, if you'll notice, we can use these same properties whether we're dealing with numbers, whether we're dealing with segments or angles. For all three different properties, we are going to be using these properties a lot the rest of the year. A lot. And over here, a little note. I highly recommend you pay attention, because these same properties, reflexive, symmetric, transitive, are used multiple times in the upcoming chapters. If you don't understand them now, you'll be lost later. I promise you. This is not a threat. This is I'm sending up flares here. Take note. I'm introducing these properties to you now so that you get used to them now. And then later on, you know how to use them. If you just blow through them now, when you have to use them later, you're going to be lost. Know the reflexive property. You can say anything like x equals itself. That's the reflexive property. The symmetric property, you can say that apples plus pears equals pears plus apples. It is a symmetric line in between two statements. Then we could go to the transitive property. And the transitive property is very, very much like the law of syllogism. You take two statements like A equals B and B equals C. You cross off what is equal, or what has occurred twice, and you have a new statement, A equals C. And that can be said for line segments or angle measures or whatever. But I really encourage you to pay attention to those three properties, because we're going to be using them a lot the rest of the year. Let's look at this problem here. 14x plus 3 times 7 minus x equals negative 1. We're going to go through and we're going to solve this using the different mathematical properties that you should already know. Let's start off with what's given. 14x plus 3 times 7 minus x equals negative 1. We don't need an explanation because that's just the given. Now, the first thing I'm going to do is I want to simplify, but I can't because I've got this problem right here. I need to use the distributive property to get rid of this. And when I do that, I get 14x plus 3 times 7, which is 21, minus 3 times x, which is 3x. And I just drop down the negative 1 because I didn't do anything with it. Now I'll notice that I've got 14x and a negative 3x. So the next step I'm going to do is simplify. And I'm going to say 14x minus 3x is 11x. And I'll just drop down everything else that I didn't use, like the 21 and the negative 1. Now I want to move this 21 to the other side. I can do that through subtraction. So I'm going to use the subtraction property. And I'm going to subtract 21 from both sides. When I do that, I get 11x equals a negative 22. Now, how can I solve this? I'm going to use the division property. If I divide both sides by 11, the 11's on this side will cancel out, and I'm left with just x equals. Now, negative 22 divided by 11 should be negative 2, and I am done. I don't need to solve anything else. I don't need to take anything else out. So, that is how we solve that problem and justify our reasonings, or write a reason for each step. Right now, I want you to solve this problem for b. Down at the bottom, I want b equals, and I want you to justify your steps. Go through that, pause the video, go through that, and when you're ready, hit play. Okay, hopefully you had enough time to solve this formula for the letter B. The first thing we did was write our formula, and that was given. The second thing we should have done was multiply both sides by 2 to get rid of this 1/2. Using the multiplication property, I can multiply both sides by 2 to make this 1/2 go away. What I'm left with is 2a equals bh. Then the third thing I'm going to do is use the division property to get rid of the h. I can divide both sides by h, and when I do, this h cancels out, and I'm left with just b by itself. Well, that equals 2a over h. Well, at that point, I'm done, because b equals 2a over h. Again, be able to solve a problem, justify your reasonings using algebraic properties, because those same properties and the way that you go about proving something in algebra is the same thing that we're going to do coming up in Chapter 2 using geometry proofs. So let's look at your homework now.